Sorry if you can't see. As always, I realize that's a big TV, but sometimes still not big enough. So this will be the first section, and I don't know how many of these there are. So if you happen to come across the exact same problem, then you're like, ooh, neat. But so what we're trying to do here is look at two linear functions and make comparisons about them. And delta math will help us because rather than do this algebraically, which by the way we could do, we're going to do it graphically. So the first one, tree A. So Jace moved into a new house, planted a couple trees. There you go. So for the first tree, tree A, it was 12 inches tall when he planted it. Are there any contextual clues, pronouns? Oh, he, yes. So Jace is a boy. So Jace planted tree A and it was 12 inches tall. So what I'm going to do is I'm going to go down to the graph and on 12 inches, I'm going to put a dot. And then tree A also grows by 6 inches per year. You can see that right here. Tree A grew by 6 inches per year. So I'm going to go to 12 for tree A. I'm going to click. And then when I go to 1 year, which is right down here, I'm going to add 6. And what would that be? 18. So you know then after 1 year that this has to be true. So what we have here is a linear model for the growth of tree A. Follow? And then I'm going to do the same thing for tree B. And tree B started out as 24. And obviously, the way these problems work is tree B can't grow as quick. If tree B grows as quick as tree A, then it will never cross, right? They might be parallel, or tree B could take off, So what's going to happen is you're going to have one that starts lower, grows faster, one that starts higher and grows slower, which inevitably leads to a crossing point, right? And that's really what we're searching for. And then we'll answer a question. Sometimes the question will be about how much time. Sometimes the question will be about the height. This particular question is about, says determine the height of both trees at the time when they're the same. So we're not going to answer this question in terms of, oh, it takes 3 years or whatever. We're going to answer it in terms of, oh, when they are the same, they are this tall. So anyways, back to tree B. Tree B starts at 24 and grows by how much? 3. So I'm going to go to 24. And then after 1 year, I'm going to go to 27. And so what we're interested in, I hope it's obvious, is we're interested in this point right here. That's the point where their heights are the same. And so I'm going to answer this question again. You got to read your questions. If it said, how long does it take before the trees are the same height? Then we would say 4 years because it's above the 4 where the lines cross. But we're not interested in the time. We're interested in the height. So what would I answer this as? 36. So the answer is 36. And then it's going to give me a drop down here. And I have to make sure I answer the question in the correct context. So this is not inches per year or years. This is just straight up. They are both 36 inches tall. So that's what we're going to be doing here. Let's see, find another one here. Got to zoom out a little bit. Andres, 2 truck rental companies. Company A charges $10 and then $2 a mile. So how am I going to graph that? Right. And so notice you got to do a little bit of math here. Notice what the time axis goes by. 5s, right? So you got to do math. You got to have your head where the sun does shine and think about, okay, after 5 years, or excuse me, after 5 miles, how much would the charge be? $10 more, right? 5 times 2. 5 miles, $2 per mile. So I can go to the next, so I start at 10. And then if I go 5 miles, then I have to pay how much? 10 more to take me up to 20. Everyone okay with that? 5 miles, $10. And then for truck company B, they start at 50 and only charge 1. So I'm going to go to 50. Now, this can be tricky. What would be another good point for me to graph? It's $1 per mile. After 10 years. Right. So after 10 miles, I made the same mistake. 10 miles, then I know that. And the reason I might want to pick that is because the graph scales by tens. For the record, I do believe you could do 5 and 5. Do you see how it kind of clicks into place there? So you could do 5 and 5, or like Bryce, I think that was a really smart thing to say is why don't we go 10 miles and just go to the nice whole $10 that you can pick as long, but again, you have to do a little bit of math to figure out that second point. And so this particular question says, graph each function and determine the number of miles driven that make them cost the same. So what would I say as far as the number of miles driven? Good. So you don't want to make the mistake of putting 90 here because it doesn't ask us how much would it cost. It asks us how many miles do you have to drive each truck to make them cost the same. So this time I would choose 40, and my drop down, I'm going to choose miles. Right? So watch out for those distractors. Don't pick the wrong units because it'll count it, just as wrong. Doesn't care. Like if your units are wrong, then adios. So that's that. Any questions about that? I shouldn't have any troubles with that. The other section that I wanted you to do was evaluating piecewise functions. So a lot of this is not going to be anything new. So like this one you did yesterday, but the reason I assigned this is because these functions are a little bit wonky. They're piecewise, so they come in pieces. And so if I said to you, what's f of -6? What would you do? So the x-axis -6, and then what would I do from there? Count up or down, in this case up until you get to the graph. And if I go to -6, I have to go up to what? 5. Good. So I would just type in 5, hit submit. Let me see if I can find an interesting one here. That's not interesting. Well, I'm just going to pick one because as I click through these, kind of the same thing happened last night when I was clicking. They all aren't what I want them to be, but that's okay. What would you say on this graph if I asked you, which I'm not, so here, let me scroll so you don't read it and get confused. What if I asked you for f of -3? This is an interesting function because it has what we call a discontinuity. It has a hole. Just got to turn it on before it'll work there, ding dong. So I want you to notice that this point right here is hollow. Do you see that? That means that that is not a point on the graph. But then I want you to also notice that directly down below it, this one is solid. That is the output or an input of -3. So if you find yourself in a position, which you should at least a few times, if you find yourself in a position where you have to choose between two dots, there will not be two solid dots. Otherwise, it's not a function, of course. So if there's a solid and a hollow, don't pick the hollow. The hollow is not the point that we're looking for. The solid is the point. So if I asked you again if I asked you for f of -3, what would you say? You would say -3 because we like this big red point down here, not the hollow ghosty looking one. Does that make sense? Does that make sense? Okay. So that's what I have for you today is just a quick delta math. Again, like yesterday's, I don't imagine it's going to take longer than 15 minutes. Be surprised if it does. And that's that. All right. I'll leave the recording paused just like I did yesterday. And if you have any questions, then that'll allow me to get in and put them on video. I just found this one. You're going to get to one of these, and I forgot to ask. What would you guys say if I asked you on this graph for f of -1? Good job, Mari. It's exactly right. It's undefined. And you might have noticed, I think, Mari, you spied that there's a button down here for undefined. If I go to -1 on the x-axis, so let me make a mark on the x-axis at -1. So there I am waiting at -1. If I look up, I never see the graph. If I look down, I never see the graph. That point is not on the function. It's not in the function. So you're exactly right, Mari. You would pick undefined. This input value does not have a defined output value for this function. You with me? Okay, cool.